Alright, starting with 3 and 4, we have inverses. If you guys remember the word inverse, I always say the word inverse sounds like the word reverse. And the reason I pair those two words quite often is because that tells you what to do. So normally we say that f of x is the same thing as y. Well, if I'm trying to find an inverse, what I want to do is I want to reverse x and y. So instead of y, I'm going to say x equals 2 times y minus 7 all over 3. It's just the x and the y that we're switching. And now we want to get rid of this 3 that's in the denominator. Well, if it was being divided, we're going to now multiply by it, which brings us to our next step. We need to get rid of the 7 first. So when I add the 7 over on the left, and our last step is to divide by 2. Now, if you remember, this unit was very heavy with function notation, so in my final answer I'll have my 3x plus 7 over 2, but now we want to set it equal to the inverse. So for our inverse we say f inverse of x. And there you have it. Number 4, same way. We can call f of x y, but then we're going to reverse. We're going to say x equals 2y to the 5th plus 7. Same way, get rid of the 7. So over on the left we have x minus 7. Now I think a lot of the times people confuse what to do in this next step. They don't know whether to get rid of the 5 or the 2. You have to get rid of the 2 before you can get rid of the 5. So from here I want to take the 5th root, and when you do take the 5th root, make sure that this entire fraction is underneath the 5th root. And all that does is it cancels. So we have the 5th root of x minus 7 over 2. And again, we're going to insert that notation. Instead of calling this y, we're now going to say the inverse, so f inverse of x.